So what you need to know for this course? So we need to know a little bit about Unix operating system, because as I said, it's best to work with terminal. I'm going to show you at the end of this discussion how to work with the terminal for Python. Okay. Now, Unix, the operating system comes in three categories. One is Unix OS, other two are Windows and Mac. So Unix OS, I mean, I really need the terminal information only, but just to get an overview. So there's hardware sitting here, which is not software. Like it's just basically all the transistors and this hardware, CPU, memory. But all this, I mean, this hardware is dead without the software. The something which will tell it what to do. Okay. Now the software is the operating system, which makes it alive. Otherwise, this guy will not respond at all. Okay, it's like as good as powered off. Now, when I boot the machine, when I turn it on, this from the hard disk, it gets loaded. This operating system gets loaded in RAM, and that's where the operating system sits. It's called kernel. Okay, so Unix kernel or Linux kernel is the basic software which will make this units work. Now, above the kernel is not where I talk to. Okay, kernel is basically all the zeros and ones, and I don't know how to program it. Of course, there are people who program it, but anyway, these are very hard to program at kernel level. But as a typical user, I work with shell. So shell is an interpreter which works between the kernel and the user. Okay, so when I copy a file, I basically talk to the shell by this command called copy command. Okay, so shell is a interpreter which is talking to the user. Okay, now I'm going to open a shell after this 3-4 slides. Okay, now you have to wait for it. Now on top of shell is this application software. Now application software, like one example is mail server or FTP, which is for data transfers, or browser, or Python when runs on is an application. Python, of course, this application will convert finally the code into objects like zeros and ones, but Python program is an application. Okay, word processor is an application. Okay, now that's what I've written in the next slide. Well, not yet. The next after that. So what is there in shell? Shell. So this our files are all organized into directory structures, and the shell, which I'm going to show you a bit later. Now, the basic commands you should know is called ls, which is listing of the files in a directory. CD, change directory. You can go from one directory to the next directory. PWD, present working directory. CP for copy. MV for move. So you need some of these stuff. Well, right now in Windows or in Unix itself, Linux, we can do things by mouse click. You don't need to remember these commands. I don't normally need them, but these are the Unix commands. Okay? Some of it you may need, like for setting the path, you need some of it. Okay, when you run on a terminal. So I recommend that you can do a tutorial of Linux, and you can use. I mean, this is slightly old. You can find in the internet some tutorial. Now, editor. Also, we need an editor, which I will tell a bit later. So, where I write my code, this Python code will be written in an editor, and I will also tell you. I mean, there's a free editor which is very nice. Okay, but you may choose your own editor. Like gedit is one, which is free GNU editor. But Windows also has its own editor, so don't worry. I mean, you can use any of these editors. Okay. Now these are various operating systems like Windows and OS X. So Windows is, of course, everybody knows about it, but OS X is for Mac, operating system X. But OS X is essentially Unix. It has something built on top of Unix, so it is kind of friendly interface, but is essentially Unix. Now, in addition to this OS, which are for computers, we also have OS for tablets and mobiles. The Apple's operating system is iOS for mobiles and Android for Android phones. These were Google. Okay, so that's what. So applications are. I just listed some of them: Python, MATLAB, word processor, browser, mail. Now, the other application, compiler or interpreter, like Python interpreter is sitting here, but C compiler, Fortran compiler, they are also applications. Okay, and they convert your program into zeros and ones. So that's sitting there. It basically will generate something which can be run at kernel level, and everything runs at the kernel level. No? Please remember. So your mail is basically running at the kernel level. So character manipulation, all that will be done at the kernel level by CPU. So programming language, I already discussed that. So there are basically many programming languages, but as an application scientist, you need to know one of these three. But I will not do it in this course. We focus on Python. I discussed what is the difference between compiler and interpreter in the last class, so I will not do that. So one thing you should know that interpreted languages are slower than the compiler languages. The Python code is typically slower than C, C++, or Fortran code, but it's much easier to code in Python. Okay, and Python has lots of libraries which are fast. It's very convenient to work with Python. Okay, so faster to code, and that's also time. Huh? I mean, programming time is also very important. Python. I would request you to install Anaconda on your local machine, and you do all your homework or whatever projects you do it on your machine. You can just download it from website Anaconda. It is available for all three platforms: Windows, Mac, and Linux. Please install Python 3, and it's much easier to use terminal. Though you can use a GUI called Spider. But I recommend that use terminal. On terminal, use type this. Okay, IPython minus pylab. So pylab imports some libraries automatically. Okay, like plotting library will import it automatically. That's why I recommend that you can use IPython with this option. Okay, so this is a brief overview of software aspect of a computer. Okay, and some instructions on what to do with Python. I mean, how to download Python and do it. And you can just do it easily. Just click the Anaconda file which comes after download, and it will install. You have to be careful where is it installing it, and to run it, you need to go to that particular directory. Okay. So what is the directory? If you just look at this finder. So if I look at this is my home directory. Yeah? So home directory has many subdirectories. I mean directories within directories. And if I just open this, then it has all many. Well, it's not even right now. It is too many of them, so it is not. So if I just look at let's say something like public, then I find why it is too slow. Okay, public, there's nothing in it. Okay, so if I look at documents, then I'll find all these documents. Okay, so subdirectory. If I just put something here, then I find more information or more files. The files within that. So this is called directory structure. It's like a tree. So finally, we'll have file at the end. Okay. So as I said, you don't need to do CD here. I mean, if I use this interface, which is available for Linux as well, I think Windows 2 would have it, has it actually. So you just go down like that. So I don't do CD, change directory, and go to file. Now we can use this terminal. Okay, so can you see? I mean, I'm sharing a screen. So this is you'll see this kind of a black dabba box, both in Linux and Mac. For Windows, you need to install this. Huh? Now, please learn from Google how to install terminal in your machine, and you can So I'm working in my home directory. It's called home user/user/mkv is home directory. Now you'll get prompt something like this. Okay, I mean, your prompt may be a bit different. And this called bash. This called shell. Now, right now I am running ZSH. So Z shell. You can see ZSH sitting here. ZSH. Okay. Now here my path is properly set. So path is when I type some. So this is a command. Okay, IPython is a executable file. Now it is basically a binary file. Now it has to know where to search for this binary file, IPython. Okay. Now, so I have a path which is set. Now let me just tell you a little bit. But please don't ask me. I mean, I think you do Google or ask your friends. Basically, the computer science guys will know for sure, okay, how to do it. But you should know this stuff. So if I do ls minus a, so this ZSH RC, okay, ZSH RC has the path. If I do vi ZSH RC, vi is the editor, okay. So ZSH RC, so you see that path is here. So the OS will itself will have its path. I mean, knows where to search the binary and so on. But for Anaconda, I need to include this path further. Okay. So these where this IPython is sitting here. So I need to include this path so that I can run Anaconda IPython. So I mean, all this best to learn yourself, and please don't ask me. Okay, I mean, and there's no TA for this course, so some of it you have to struggle. So now if I just say IPython, because it knows where to search for it and run this application, minus, whether it's visible to everyone, I can make it a bit bigger. Okay, so this is what I type. So it will open up. What happened? IPython minus by there. Okay, so it has opened Python 3.74. You can see this command here, and it has also opened. It has also imported. Imported means it has basically brought in some more files for plotting and also for some number crunching. Okay, so let's start doing some simple just for illustration. Though we'll do it a bit later. So x is, let's say, pi. So x is pi. So what is x? I just type. So x is 3.14. So this is double precision, no? I mean, how many digits are there? You can see it's a double precision. Okay. Now I can do sine of x. What is sine of x? So it should be 0, right? So you get a small number. It's 10 power minus 16. E minus 16 means 10 power minus 16. It is 0. I can generate an array. So let's put an array 1, 2, 3, 4, 5, 7. Now so this is x is an array, okay? Now y is x squared. Okay. Now it turns out it is not allowed for x because x is a list. It doesn't allow the square operation. So I need to create a real array. I mean, so now don't worry about all this. We will learn it a bit later. So this is x. Now I can do y. So this is a numerical array, okay, and that I can square it. Is y is so I can say y. So it's a square of all the numbers of this array. So 1, 4, 9, 16, 24. Now I can plot x comma y. So it plots with 5 points. So it's just as simple as this. And you can do this within something like 2 weeks or 2 weeks. You can start doing this kind of. Yeah, so you can see this very trivial to program in Python. If I were to do in C, then I had to learn how to compile it. I had to write the whole code first, then get the result. And for plotting anyway, C plotting is very tedious. It can plot, but it's just too tedious. You'll have to anyway use Python or MATLAB or something to plot. So that's why it's good to learn Python for at least for all these simple operations. But we can also do more complex operations. Huh? Whatever you can do in C can be done in Python.